let's take a look at this example. This time we have current source, we have resistor, and we have voltage source. All of them are connected in series circuit. So what you're supposed to do first, you're supposed to realize that the current IS will be my current which will go through resistor R1, right? And my voltage source, right? This is because in the series circuit there is only one current. Okay, so this is going to be my IS. So I have I1 is equal IS. Okay, so this is equal 10 milliamps, and the direction of the current is going to be this way. Okay, the current is going to go in this way. This is going to be the direction of my current. So this is my I1. Next, we're supposed to calculate Vs. Vs voltage across my current source. Okay, voltage between this point and ground. So what I have to do first, I'm supposed to find voltage across resistor R1. So if V1 is equal I1 times R1, where I1 is equal 10 milliamps, and I multiply this by 3.3 kiloohms. Okay, so this is equal 33 volts. Okay, you can always use the calculator. I'll show you how to do this. On the calculator, I have 10 exponent 3 negative times 3.3 exponent 3, because we have K. This is equal 33 volts. Next, you're supposed to realize that the voltage across the current source is the sum of these two voltages. Okay, this voltage plus this voltage will give me voltage across the current source. So Vs is equal V1 plus IE. Okay, please keep in mind that, let's say, when current goes in this way, so I'm going to write over here positive sign, and when the current is leaving the component, we always write negative sign. Okay, so simply please notice that let's say positive terminal is connected to the we can say like negative terminal of my resistor. Of course, resistor has no positive negative terminal, but let's say the direction of the current forced me to write over here positive and negative over here. So positive goes to negative means we have to add these two voltages. Okay, in other words, if you want to find the voltage between this point and ground, you simply go this way and you see what positive sign. So this is positive voltage, and I have positive sign over here, so we have to add them up. That's why I write Vs is equal V1 plus E, where V1 is equal, we said, 33 volts plus E, which is equal 15 volts. So this is equal 48 volts. Okay, so we found Vs, we found V1. Now we're supposed to find P total. P total is equal, because I have just one resistor, so this is I1 square times R1. Okay, you can use this formula, or you can use P total is equal V1 times I1, or we can say V1 square over R1. You can use either one. Okay, I'm using the one with the current, so I have I1, which is equal 10 milliamps. I raise this to the second power, times R1, which is equal 3.3 kiloohms. So my P total is equal 10 exponent 3 negative to the second power times 3.3 exponent 3. This is equal 330 story milliwatts. Let's check one more time. We're supposed to determine the magnitude. We found the magnitude, the value of current I1. We found the direction. Okay, current is going to go this way. And we have V1. We said V1. We have voltage source. We have P total, so we can say that the problem is solved.